Hello everybody, my name is Sukji Kwan and I'm here to talk about a very strange phenomenon that has plagued the minds of scientists and philosophers since the very beginning of time itself, gravity. Now, before you dismiss this video as just another boring lecture about balls falling and planets orbiting, you might want to stick around because this video is going to throw your current understanding of gravity out the window, violently. So without further ado, let's get right into it. But before we talk about anything interesting, I think it'd be better to bring it back to the basics for a moment. First, I think we should ask a very important question to ourselves. What exactly is gravity? We were all told in school that gravity is defined as a fundamental property of objects with mass, and that anything with mass has its own gravitational field that affects other entities. At first, that in itself seems kind of odd, that people like you and I are able to produce gravity and make surrounding objects attracted toward us. In actuality, however, that level of gravity is pretty much negligible, because the gravity that you and I see every day is the gravity that holds us to the Earth, which is a much larger object than both you and I. So that would mean that gravity is proportional to mass, to some extent, and that a greater mass results in a higher gravitational pull on other objects. So up to this point, everything is fairly simple. Gravity pulls objects towards each other due to some force of attraction. Quite literally, there are no strings attached. But this is where it all gets interesting. I'm sure you've all heard of Albert Einstein, correct? He was known to have surpassed many others in ingenuity, and for very, very good reason. Perhaps the theory he's most famous for is his theory of general relativity, which I'm going to shorten to GR because we're going to talk about it a lot in this video. GR was a revolutionary step away from standard Newtonian physics and more into the modern world of theoretical physics. Before GR, there was no logical explanation for why gravity existed. The theory essentially stated that gravity is due to the curvature of space-time caused by the uneven distribution of both mass and energy. I know you might be confused right now, and frankly, this isn't very easy to explain either. But for now, let's elaborate more on the curvature of space-time stuff. Now, perhaps one of the most interesting mysteries of physics for millennia was the cause of gravity. The ancient Greek philosopher Aristotle believed there to be a supernatural force he called gravitas, or heaviness, that caused all objects to fall to the center of the universe. However, Galileo, a renowned astronomer of the 17th century, did conduct an experiment that proved that all objects fell at the same rate, 9.8 meters per second squared, with slight discrepancies due to air resistance. Then, Isaac Newton came along and completely revolutionized physics by formulating algebraic equations in order to calculate certain parts of our universe we would usually not be able to find without experimentation. He made the universal law of gravitation, which is still taught in schools everywhere. The universal law of gravitation is essentially that the mass of two objects multiplied by each other and divided by the distance between their centers squared is proportional to the force of gravity between them. This proportion was turned into an equation when Henry Cavendish threw in the universal gravitational constant, which was determined in 1797. However, all the equation did was summarize the effects of gravity, not yet the direct cause of why it existed. And at the time when general relativity came around, most physicists just assumed that gravity was just simply a direct result of mass. Once general relativity was established, people's views of gravity were completely changed. A theoretical physicist and Einstein's former tutor, Hermann Minkowski, interpreted general relativity and came to the conclusion that gravity is just a direct result of objects trying to follow the fundamental laws of the universe. Let me get into a little more about what this means. Now, the universe has a few rules that it must follow without exception. The first rule is that if one moves through space, one must also move through time in order to do so. And that seems pretty basic, right? If I move an object from here to here, it takes some time for me to transfer the object from one position to the other. The second thing is that both space and time are part of the same four dimensions through which we observe our universe. Three dimensions include height, length, and width, depending on the reference frame. But what is hard to imagine is that objects actually move through a fourth dimension, time. From Kurt Vonnegut's novel Slaughterhouse-Five, it is said that if we were able to physically see the fourth dimension, we would be able to look at all the different moments, just the way we can see a stretch of the Rocky Mountains. That's just an interesting way I like to think about the fourth dimension. Einstein liked to call these four dimensions space-time. A misconception people often have about space and time is that it is possible to move through time without moving through space. But according to Minkowski, since space and time are in sync with each other, one cannot move through time without moving through space. At this point, you're probably wondering what any of this has to do with gravity. Here is where it all comes together. By simply existing, any matter distorts space-time in order to move through time, while also moving or accelerating through space. And that magical acceleration is gravity. What? If that doesn't blow your mind, I honestly don't know what will. Various scientific experiments have supported this theory, including Arthur Eddington's experiment on the position of the stars before and after a solar eclipse. When the solar eclipse occurred, Eddington observed that the stars appear closer than usual, showing that the sun's gravitational distortion of spacetime causes even light, an entity without mass, to bend around it. So the next time somebody tells you that gravity is just some magical force that has no explanation, don't be afraid to correct them. So in case you didn't catch everything in this video, I'm going to post a few links in the description if you want to do some further research. But can we just take a moment to think about how weird the concept of gravity is? Like, I shouldn't be the one to say because I'm the one trying to explain it to you guys, but it is probably the strangest thing in the entire universe. Thank you all for watching, and I hope you have a relatively wonderful day. Bye.